Welcome back, students. This is the Q&A session 16 from the chapter of work, power and energy. The topic is rebounding of a ball after collision with the floor, and this is a very small, very easy question which I have taken for this session. So this session number 16 is in continuation of this session number 15, in which I have discussed the important formulas pertaining to this topic, that is rebounding of a ball after collision with the floor. So based on that session number 15, I have taken one question for this session. This is a very easy question, and I have taken this session in order to just make you understand how those formulas can be used in solving the questions pertaining to this topic. So here a ball is dropped on the ground from a height of 2 meters. If the coefficient of restitution is 0.6, then the ball will rebound to a height of. So there are 4 options given here, and we have to find the correct one. So in the previous session, we have seen that the height of the ball after the nth rebound is equal to e to the power 2n into h naught, where h naught is the initial height of the ball. H naught is the initial height of the ball. So in this case, h naught will be equal to 2 meters. This is equal to 2 meters. And here E is the coefficient of restitution, which is given as 0.6. So the height of the ball after the nth rebound is given by this formula, that is e to the power 2n into h naught. Now in this question, it is we have to find the height to which the ball will rebound. Rebound means a ball is dropped from a certain height and then it will touch the floor and it will rebound. So here n, the value of n will be equal to 1, because here we have to find the height to which the ball will rebound. That is, it will drop on the floor, it will touch the floor and then it will rebound. So here the value of n will be equal to 1. So if n is equal to 1 and E is equal to 0.6, so E is equal to 0.6, n is equal to 1, so that is equal to 0.6 to the power 2 into h naught. H naught is equal to 2. So this is equal to 36 by 100 into 2, which is equal to 72 by 100, and this is equal to 0.72 meters. So the ball will rebound to a height of 0.72 meters. That is our correct option is A, that is 0.72 meters. So now from this question we can also find I have discussed 4 important formulas. So in this question we have found the height to which the ball will rebound, which is equal to 0.72 meters. But there was one more formula, that is the total height traveled by the ball before it stops bouncing. So here we had one formula which was given by h naught, 1 plus e square divided by 1 minus e square. The total height traveled by the ball before it stops bouncing. That is, if I am just dropping one ball from a certain height, then it will when it drops on the floor, it will rebound. Again, it will drop on the floor and rebound, and finally it will come to a rest on the floor. So in that case, what is the total height traveled by the ball? This is given by this formula. Here h naught is the initial height, which was equal to 2. The value of E is 0.6 to the power whole square divided by 1 minus 0.6 to the power whole square. So from this formula, you can easily calculate the total height, which is equal to how much? If I just this is equal to 1 so this will be equal to 1 plus 0.6 whole square. This is equal to, it will be 1.36 divided by 0.64, and this is equal to 2 into 1.36 divided by 0.64, and this is equal to, if I calculate it, this will be equal to 2.72 divided by 0.64, and this is equal to 2.72 divided by 0.64. So this is equal to 2.72 divided by 0.64. So this is equal to 4.25 meters. So the total height traveled by the ball before it stops bouncing is equal to 4.25 meters. So in this way, you can utilize all those 4 formulas which we have discussed in the session number 15. So this is the means in this question we were simply asked to find the height to which the ball will rebound. That is, so that we have already calculated, that was equal to 0.72. But this was an additional means I'll just show you how we can use those formulas in order to find the different parameters. So that here I have also calculated that the total height traveled by the ball before it stops bouncing by using this formula, and this is equal to 4.25 meter. So thank you very much for joining this session, and in the next session I will be coming up with some different type of questions based from this chapter of work, power and energy. So thank you very much and have a nice day. Bye.